Lesson 11. Curl. Section 11.2. Curl. Let's see what the meaning of the curl of H is. Let's consider a surface S. This is Ampere's law. The infinitesimal line integral of H along dCp per differential surface ds is the definition of curl H, and it is expressed by this equation. The graphical representation of the curl of H looks like this. The right-hand side is transformed into the component of the current density J, normal to the differential surface ds. Since this equation holds for any dCp, the curl of H equals J. Now, let's see how to calculate the curl of H. A differential surface ds can be decomposed into three components in Cartesian coordinates. The first component, ds1, is parallel to the yz plane. The second component, ds2, is parallel to the zx plane. And the last component, ds3, is parallel to the xy plane. Let's look at the differential surface ds1. It is encircled by the closed path dCp1. The unit vector normal to ds1 is denoted by ax. The curl of H along dCp1 is expressed by this equation, where ax is the unit vector, and dy dz is the area of ds1. This is the x component of the curl of H. The four corners of ds1 are denoted by 1, 2, 3, and 4. The line integral along the closed path dCp1 can be decomposed into these four line integrals. Along the path from 1 to 2, the component of magnetic field strength is expressed as HYAY. Thus, this integration gives HY dy. On the path from 3 to 4, the y component of HY differs slightly from that on the path from 1 to 2. It can be approximated by this formula. Thus, the third term gives this result. Along the paths from 2 to 3, and 4 to 1, the z components of H contribute to the line integrals. And these are the results of integration. By substituting the integrated equations into the numerator, the x component of the curl of H is derived as shown in the bottom equation. Next is ds2, which is parallel to the zx plane. This is the y component of the curl of H. In the same way, the y component is derived as shown in this equation. The z component of H is obtained as this equation. This is the curl of H in Cartesian coordinates. Exercise 11.2. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.